3, 2, 1.
Welcome, everyone. Thank you for joining us on this Friday afternoon. I'm glad you're here. My name is Chadwick Smith. I'm a principal consultant and data architect with Improving Atlanta. Today's talk is an intro to modern data. I've tried to make this presentation for a pretty broad audience. It could be for salespeople, people in architecture, executive leadership, data engineers, developers, anybody really. So it's fairly high level. It provides context and a lay of the land and a sense of industry trends. And one more note on that, when I'm talking data, for the most part, I'm focused on analytics and OLAP, not so much OLTP. I'm thinking in terms of data warehousing and that kind of stuff. So let's get started. So you've probably heard a lot about modern data architecture. The times they are a-Changin. And I would like to say that from my perspective, the change has come in two different waves. Roughly 5 years ago, from the consulting side, we started noticing that data warehouse projects started to dry up. Those old traditional stick 3 data developers in a closet for 9 months, hope they come out with something useful approach, we started seeing a lot less of that. And a focus shifted to smaller scale data deliverables with a faster turnaround using tools such as Power BI. I would also like to say on this timescale I'm using of this 5 years ago and now, this is mostly from the perspective of a mid-sized company. Your Fortune 100s are and your big tech companies are going to be ahead of the curve, as it were. But this is in a sense of what we've seen in the consulting world since most of my clients have been in the mid-range. So today, what is happening is I would call it the second wave. The traditional has kind of, I would say, matured and settled. And now what we're seeing is a big shift in the industry towards new technologies, mostly cloud-based, not totally, but mostly, which promise faster insights and lower maintenance. One of the biggest, I think, factors in this right now is that the cloud has really matured from where it was 5 years ago and certainly 10 years ago. So let's talk about why is this change occurring? Why are so many organizations modernizing or thinking about modernizing? You may have heard some of these quotes before. I chased down the original quotes, and 20 years ago, someone said every company is a software company. 6 years ago, someone said it's now true that every company is a data company. And companies are realizing that they can gain a competitive edge depending on how quickly they can get to their insights in order to drive decisions. The other quote you may be familiar with is actually from 15 years ago now. It's starting to feel a little old, and that is data is the new oil. This was a quote by someone who was pointing out that raw data has almost no value, and you have to go through an extraction and refinement process to really get the value out of it, and that process is very laborious. Today, data is valuable, and we have better and faster ways of getting to it. I would add one other thing on why the change is occurring in terms of opportunity. There's a lot of disruption occurring in a lot of industries. COVID is just one example of that. Even if COVID had never happened, the disruption would still be going on. And to manage the disruption and to reap the opportunity from it is what a lot of organizations are looking at. In addition, the reason behind the change is that there's a challenge. There are 3 competing problems that almost every organization is facing. Data is exploding along 3 different axes. It is coming in faster. There's more variety. We have a lot of mix between structured and unstructured data, like video and audio. And of course, there's a lot more data volume. So each of these things has expanded and is continuing to expand. I like to think of it like the Big Bang, where things are still accelerating and it's still expanding outward. The problem is with traditional approaches, with traditional relational databases, and even your big data, Hadoop and Spark and what have you, they're having a hard time keeping up. They require higher maintenance, longer build times for development efforts and projects. They don't have a whole lot of flexibility once built, and they are largely based on ETL and batch processing, and those ETL and batch processes are taking longer and longer to run. So all that is happening, but we want to compete in the marketplace and we want to get to our data faster. So enters modern data. What is modern data? This really helped me when the light bulb came on and I realized that for a long time we had traditional data and big data existing side by side. About 10 years ago, I think many of us were wondering, should everyone learn Hadoop? Is it going to take over the entire ecosystem? And I would say that it never really did. It grew and it became very prominent, but it never took over. For one reason, its special purpose was in terms of batch analytics, but also because even though it's great at handling large volumes of data, it is very complex and very expensive. So really what has happened is modern data enables us to use all of the approaches from both traditional and big data and kind of under the same umbrella. And what is driving that, as I said, is there are a lot of more cloud-based features and services out there. We have better transformation tools and more integration tools. An example of integration tools are integration services that provide point-to-point, A to B integration at the touch of a button. Companies like MuleSoft and Zapier come to mind in that space. So the plumbing and the hard work of connecting data and getting it to flow is becoming more convenient with the use of more powerful tools. So let's talk about what is changing. When we talk about modern data and modernizing and all of this stuff, what exactly is changing? Well, on-prem to cloud is part of it, along with other infrastructure migrations. That's definitely part of it. But also within the cloud, there is a shift from IaaS to PaaS services, platform as a service, which means getting off of VMs. Organizations are using less and less VMs because they're getting out of the constraints that come with them. And I added data warehouse to data warehouse as a service. Is a subcategory of IaaS to PaaS because now there are actual data warehouse as a service offerings out there which are more flexible and require less maintenance. So I mentioned the constraints of VMs. I ran into a classic example of this recently. A SQL server that we're using to run migrations on ran out of disk space, and the answer from infrastructure was, well, you need to anticipate disk usage and provision it ahead of time. Well, that's true, and I understand where he's coming from. It is also very difficult to do, and it takes a lot of time. So a lot of the PaaS features in the cloud enable you to scale in terms of disk space and processing infinitely, which makes things a lot more powerful. Along with that, I would say in the cloud, you also have to take care of your cost optimization, because even though you can scale infinitely, nobody has infinite money. So let's also talk about other changes going on in the data space with modern data. Companies are focusing more on data analysis than data wrangling. And tools, like I mentioned, Power BI, that's the fracking part of data is the new oil, enable analysts to get to the data to have quick and direct access to it. In addition, new approaches and technologies are enabling ELT. This is extract, load, and then transform. Capture the data first, model it, and use it later. This is a technical change as well as a philosophical change that a lot of organizations are using to get insights quicker. Another tool, by the way, in that space would be Databricks, for example, which can do all of the ETL, data modeling, and visualization and machine learning all within one interface. So another thing to note in the move from relational to data lakes is that some organizations, 80% of their data is totally unstructured. Video, audio, chat logs, Twitter feeds, what have you. And with so much unstructured data, we need a place to store it that's easy to store, and we can figure out what to do with it later. And that's where data lakes come in. And these services and features around data lakes are expanding every month. And in fact, there are even on-prem data lakes, which are a possibility now, for example, SQL Server 2019. So, okay, we've talked about what is modern data, why is it changing, what is changing exactly. Now let's try to draw back and look at the overall ecosystem. Let's ask the question, what's on the map? If you first start exploring what is in this modern data landscape, you will find that there are a lot of uncharted territories. And if you're a cartographer, you might be tempted to just draw a dragon and say, yeah, that must be what's over there. It is kind of like an undiscovered country. So in my own personal search for a map, I came across this large thing here. This is from a I would call him a data journalist in some words. His name is Matt Turk, and this comes from his 2020 Data and AI Landscape. Now, if a data architect looks at this and is overwhelmed, I can just imagine how other people feel. This is just too much to take in. So I sat down, did a whiteboarding session over several days with a couple of my other architects at Improving. And we said, okay, really, let's simplify this. And we came to this. Now, this is still a lot of words on the screen, but at least we've broken it down into categories if you focused on the words in bold. Great, okay, it's a little more simple, but what is going on here? 10 years ago, it wasn't like this. What is really going on? Why is this so complicated? And how do we conform what we're seeing in the data ecosystem today to the data vision for the organization that we serve? Well, it used to be a simple story. Just about every data warehouse project had a very, very simple architectural drawing that looks something like this. I chose this graphic because I like the kindergarten colors here. It was really, you have your sources, you're going to extract, transform, load, and then you do data analytics. It was a simple concept, even though it was hard to implement. I would call this the, by the way, many to one process. Many sources on the left, one output on the right. Today, we have multiple arrows. We have arrows all over the place. This is from one of Microsoft's reference architecture diagrams. Now, I don't know about you, when I look at this, it's kind of like one of those weird paintings at the museum. I have to stare at it for 30 minutes before it starts making any kind of sense. The reason for this is that three things have exploded. What you can do to the data, all those features in the middle of the screen. The number of data sources on the left-hand side have exploded, as we discussed, along those three axes. And then the use cases and the users, the data users on the business side and otherwise, and applications. There are more than there ever were before. What we have, in a sense, is a many-to-many relationship. So it's gotten more complicated. I borrowed this slide from James Serra, who is a big data evangelist at Microsoft. And he said, considering the complexity, our job is like this. And then he put another slide up and said, really, it's more like this. At least this is how it feels. So this includes not only all the cloud technologies, but the on-prem as well. So then the question becomes, how do you propose a pile of Legos? And when I say propose, I'm talking about you could be a data engineer, you could be a data architect talking to a CTO, you could be that CTO going to the executive team and seeking funding for new initiatives. You could be a chief data officer proposing a data modernization roadmap. Whatever proposing these initiatives looks like, from whatever position you're coming from, the job, I would say, has gotten more difficult. Before, we started simple and it got more complex. Today, we are starting with complexity and our job is to simplify it. One way to simplify it is to focus on the problems to be solved, the business use cases. So then, why the new architecture? That becomes a question in people's minds. Well, it's because each piece of the architecture unlocks something and solves a problem. For example, leveraging all this unstructured and semi-structured data we have, which we're not taking advantage of yet. Of course, with anything, you want to eat the elephant one piece at a time and perhaps do a proof of concept. I would say that you can do this more readily with the cloud because of the pay-as-you-go model with most of cloud services, where you can migrate perhaps one silo of your business at a time or one data mart in order to not only prove out the concept, but to set a precedent and to begin to shift people's thinking about how they use data. And when proposing, of course, you don't want to put those messy, complex pictures in front of people like I just did, because this is not a proposal. You want to talk about how the whole ecosystem exists, and what we're doing is picking from a menu, breaking it down into categories from appetizers to entrees, etc. And you need to know when and why you pick each item on the menu and include it in the proposed architecture. And all of this, you want to remember that the overall goal is to get to the data quicker, serving multiple use cases, multiple data users. Okay, so one question that people will have, how do you know if modern data is the right move? Because to be honest, this is not a break-fix scenario. This is not, things just aren't working for us. Nothing's happening. We need a solution ASAP. Really, it's more like the old parts have become rusty. Every change is a big effort. Every development change to your ETL pipelines, for example, is a bigger and bigger effort. There's slow delivery of reporting and analytics deliverables. When requests come in, how long does it take? Does it take 2 weeks to generate a new report or months to generate a new data mart? And meeting SLAs is becoming more and more of a challenge because of those exploding data in terms of volume and other things. Meeting your overnight ETL SLA outside of business hours may become more and more expensive to accomplish. Now, I would say that there's a bit of a, when you're asking the question, should we move to modern data? It's probably not a question of if, but when. And there's a bit of a boiling the frog situation here, because ETL changes have always been a big effort. Maybe we're used to having slow turnaround on reporting analytics requests. Maybe we've always been fighting our SLAs to get the ETL done on time. But if you notice, it has gotten more difficult over time, even with all the advances in data technology, just in traditional world to this point. So I like to think of it as buying an electric car. Personally, I don't have one yet, but I know I will one day. And the question to me is, when do I do that? When do I spend I think it's $2,000 to get that massive plug in my garage so I can charge it overnight? When do I take the plunge? And should I, one of our cars will go electric before the other one, maybe we have that option. But it's important to remember, just like with the electric car, that there are so many benefits to it that are kind of, I would say, hard to predict. But once you get it, and this is from me talking to coworkers who have electric cars, they love that they never have to go to a gas station anymore. And this is an advantage that they never thought of when they were working out the math in deciding whether they were going to buy one. There are a lot of benefits, and it makes life better, makes things more convenient, and makes things faster. So how would an organization offset the cost of migration? We would recommend doing an assessment to figure out where the organization is at, both on the business side and the IT side, understand where you are on a roadmap to data maturity, and how modernization can fit in that roadmap. All right, so if we're going to start modernizing our data architecture, what's a recommended starting point? Well, there's a shift that needs to start occurring that needs to happen in terms of thinking, if not actual action, and that is the paradigm shift of ELT. This is get the data now, figure out what to do with it later. Don't filter it, don't transform it, just get it, capture it, and archive it, and figure out what to do with it later. There may be value in certain sets of data that we are not extracting, and there may be value in historical data, which in 2 years' time, today's data will be historical data that we just don't know about yet. So let's capture all the data now. One of the best tools out there for making this possible is a data lake. And this enables you to centralize your data, combine any kind of data in one place, whether it be your traditional relational data, extracts, non-structured audio, video, etc. And you can archive forever. It is remarkably cheap. The last time I looked at the Azure calculator, for example, it was $40 per terabyte per month. And the data lake tends to have a lot of services within the cloud that plug into it and make use of it. So it opens up a lot of options. The other advantage of a data lake, it is non-proprietary. We're talking about file formats here, and pretty much all the file formats, at least the ones I'm aware of, are non-proprietary, and that means they can be transferred from system to system, technology to technology relatively easy. And of course, I mentioned the on-prem data lakes as well. That is another option for organizations that may have good reasons not to go to the cloud for perhaps really tight security requirements and what have you. There's that option as well. If you already have a data lake, then the question becomes, are you getting the most out of it? Has it turned into a data swamp? Data lakes, if you just drop things in there and forget about it, it will become a swamp. A data lake needs to be organized, optimized, and governed for data governance purposes. So I would like to throw one more metaphor at you. I do love metaphors. I hope you do too. If you don't, I'm going to make a pledge that this is the last one. A data lake is a place where it is like a kitchen, and if the kitchen is well equipped and well stocked, any cook can come into your kitchen and make it happen. They can make a delicious meal. And so the metaphor works well because in a data lake, you can have data scientists, you can have data engineers accessing the data, building different models off of it. You can even give access to certain parts of your data lake straight to your business analysts. So anybody can access it if you manage it well. And a lot of services hook into it and really leverage the advantage of ELT. All right, so another point I'd like to make here is the effect of microservices. This is a microservices architectural diagram. If you notice here, under a microservices model, there are a lot more OLTP databases. Each of the services are split out and a database for each one. So this means that centralizing data becomes even more necessary for reporting. All right, so I have talked about the complexity. Now let's spend some time breaking it down. We're going to choose our own adventure. First, let's simplify this. Let's take the arrows out of the way. All right, So what we have here is that three things have exploded. What you can do to the data, the services in the middle, storage and services, the number of data sources on the left, and the usage points on the right. So I will point out something. The data lake is right here in the middle. Almost any modern data architecture diagram will have it somewhere in the middle. I would not say it's absolutely essential, but is is the most common part of any modern data architecture. And as I said, we have the sources on the left and the use cases on the right. So now let's chart a path through this diagram. Let's do the more traditional route. We have a couple of relational source systems. We can use an ETL tool like Data Factory, which is in Azure, and load into a data lake first. Now that's not a necessary step in this case. We could go straight from Data Factory to Synapse, which is their data warehouse. But since we're loading the data into the cloud anyway, we might as well drop it in the data lake because we can use it for something else later. Then from the data warehouse, of course, we can use an analytics and reporting tool like Power BI to serve it up to our end users. Now that we have the data in a data lake, as I said, this opens up other options to do other things with it, perhaps instead of our data warehouse or in addition to it. And it also opens up other cloud services, like in the case of Azure, they call it cognitive services. This is interpreting text, interpreting images, identifying images and transcribing audio and these sorts of things, sentiment analysis, etc. With the data, imagine if you have all of your data in your data lake, then you don't have to worry about what you're going to pump into cognitive services or Databricks or other things. It's all available to them if you manage your data lake well. So when we're walking through this diagram, the good thing to keep in mind is to start with the end in mind. Who are the consumers and what are they doing with the data? Then follow the path through from the source to what you're going to do to the data to the end. And I would also point out that each end use has different needs in terms of completeness or data quality. Some will go diving in the lake. Some will need a pipeline going through a water treatment plant. I broke my own rule. That is another metaphor. I apologize. It is a good one though. And other things that are happening in the industry, as you've probably heard much about, is real-time streaming. We want to get our data fast. We want to get our insights fast. We want to monitor what is happening day by day, hour by hour, minute by minute, coming off of things such as IoT devices. So how do we do that? Well, cloud services allow you to use things like in Azure, there's Stream Analytics to process and provide quick monitoring of those stream fields. But a good way to go about this is to load the data into your data lake as well. This is for archival purposes, and typically Stream Analytics is not doing heavy, robust analytics. It's doing second by second monitoring. If you want to take a day's worth, a month's worth of IoT data and really do analytics with it and combine it with other data sources, you want to drop it off in your data lake. All right, so there's one other thing I want to point out here, and that is you may have heard about a data lakehouse. This is a term I believe that Databricks has come up with, and Databricks is positioning itself in the market in many ways as an alternative to a data warehouse. This, in my mind, there are certainly use cases for this. What I don't know is whether that will take over. Will all data warehouses go away and everything is a data lake house where we're running Databricks services on top of the data lake with no need to pump pipelines into a data warehouse? That's a question. Another thing to point out is when we talk about this data warehouse here, We don't just have to use Synapse. In Azure, for example, we can use Snowflake, so we can swap out one of the two. We have a choice there. In Azure, you have a choice between Redshift and Snowflake. In Google, you have a choice between BigQuery and Snowflake. I've just named the big four, what I call the big four: Azure Synapse, AWS Redshift, and Google BigQuery, and of course Snowflake, which can run on any of the three. And I would add Databricks Delta Lake as the big four plus one. These are all things that are happening in the industry. There's a lot of excitement behind them, and there's a lot of hype as well. Let's drill in on one of those in particular and talk about the hype and the reality. So Snowflake is caught on. I would say they were ahead of the curve, even compared to, say, AWS Redshift. For that reason, the name Snowflake gets thrown around a lot as kind of a label for the whole category of cloud data platform. And by the way, I was calling it a data warehouse as a service. They would like to call it a cloud data platform. So why is Snowflake so buzzy? They've had an adoption boom in the past few years. That has been tremendous. They also IPO'd last year. That helps. And they have the ability to work on any of the three cloud services, as I mentioned. I like to think of it as the Macintosh of cloud data platforms because it is low maintenance, it has ease of use, it's along with the third parties in its ecosystem, it is all in one. I would say it's a good introductory platform. In terms of ease of use, for example, they use t-shirt sizes to size their data warehouses or their compute nodes. So they've done some things to make it, you might call it user-friendly. The big question is, will it stick around? Is this all hype? Is it going to go away in a couple years? Really, right now, that is to be determined. The big question is, how long is it going to take for the other ones to catch up? Azure rebranded and really re-architected their data warehouse in the cloud and called it Synapse. I believe that was last year, specifically, I'm told, to compete with Snowflake. Because Snowflake runs on top of Azure and AWS and Google, it is a kind of has a frenemy relationship with each of those cloud platforms, which is really interesting. The big question for Snowflake in particular is how sticky is their product ecosystem? Will they, in 5 years, will they retain 50% of market share or whatever their market share is right now? Or will they shrink and kind of maintain a niche in the industry? It all remains to be seen. So I've talked about the hype and the promise. Let's talk about some anecdotes from boots on the ground. A Snowflake account rep will tell you that we conservatively see an 80% reduction in operating costs. And I think in some organization that's true. I did hear an anecdote from a large company in Atlanta who made a switch from Hadoop to Snowflake, and they found that it was performing better out of the box. They were shocked to find this because they had a team of people maintaining and tuning Hadoop. But I would point out, there are always edge cases. I would say that Snowflake works great for 80% of your needs, but you will always run into edge cases, and when you run into that, you may not be happy. It may not live up to its promise. In some ways, Snowflake almost over-promises what it can do for you, because when you do it, run into these edge cases, it can be quite jarring. We know of one of our clients in particular who backed out of the idea after doing a POC with us for that very reason. Another concern that some clients have voiced is being locked into Snowflake, and that is a bit of a concern. I agree with that. I understand that. But since things are so early on and Snowflake has established itself as a dominant player, migrating in and out of it is an option and really shouldn't, well, under certain circumstances, would not be too arduous. But there is the nature of it being a third party and not tied in with one of the cloud services that drives that concern. Okay, so we've talked about what modern data is. We have talked about why are things changing in the industry, what is changing, and we talked about the complexity and what's going on. And we drilled in on one example, one of the market leaders and kind of a label for the category in Snowflake. So with all that in mind, what is our role in this whole thing? And by the way, before I forget, I wanted to ask you to go ahead and put your questions in the Q&A now, because we are nearing the end. Go ahead and type those up, put them in now, and I can answer them after this slide. So what is a data leader's role in all of this? And when I say leader, it doesn't mean you have to have a CIO title or a chief data officer. You could be a data engineer. You could be an architect. Really, anyone who wants to help the organization that you're serving modernize its architecture. So the real, I think, value that we can provide is guiding the organization through this complex ecosystem. The old model started simple and got complex. Today, we are starting with complexity and simplifying it. So there's an art behind this: finding a starting point, a proof of concept, an incremental change, migrating a particular silo of the organization, etc., to help IT get over the first hurdle of showing value to the rest of the organization. And then there's also another aspect of this, which is the overall data maturity, not only within IT, but the business side as well. In order to leverage this ELT philosophy, get to data faster, a wholesale change in thinking has to occur. Now, it can be done with incremental change to the technical systems, but it requires a wholesale change to thinking. And it can be very difficult to go from a less sophisticated environment and suddenly shift into modern data and all the cloud goodness and all of these things. So there's a learning curve, and there's also an understanding of which areas can go first. When we talk about maturity, think data governance. That's a big aspect of it these days. A lot of organizations are putting a lot more attention into it, and it is really hard to pull off. It is honestly very difficult to achieve. It requires executive sponsorship and a lot of people's time. It's hard to get it right, but it is part of that larger organizational maturity, and a great example of it because it crosses over between the business users and IT. So then if we're data people and a data leader, or you're just someone who wants to help your organization modernize, I think education is key. And I'll share one tidbit I learned from a source at Microsoft. Every employee within certain departments in Microsoft are being required to get certified in Azure technologies, to get their own Azure certs as a requirement. And there are certifications like Azure Fundamentals, Azure Data Fundamentals, and even non-technical people are being required to get the certification. We are doing a similar thing within improving, and it is, I think, key to managing the change, modernizing, and helping organizations to modernize. So with that, we can turn it over to Q&A. Please type in.
We've got a couple questions. First one is, of the major cloud providers, AWS, Azure, GCP, do any have an edge in the modern data space, or are their offerings relatively complementary?
They have comparable features for the most part. I would say that Google's a little bit behind. I would rank it in this way, and this is very general. You know, it's kind of hard to answer. I'm trying not to say it depends. I would say Snowflake is the market leader still. Redshift is close behind, and Synapse is catching up. Google BigQuery, which I don't know as much about, would be the fourth on the list. However, their features are rather comparable. There's not much that one can do that the other one just can't do at all. You get more into questions of speed, perhaps, or even cost. And honestly, if you're an organization that already has AWS, you really have two choices, Redshift or Snowflake. In terms of the major players, there are other ones out there and growing, but in terms of the major players, if you're already in AWS, are you going to think about shifting over to Azure just to use Synapse? No, that's not going to happen, unless you're just barely in AWS and a total shift is okay. So narrowing it down to either the native cloud providers service or Snowflake, I think in most cases becomes the question. And in that case, would you totally lose out if you don't go Snowflake? No, it's kind of like the example where you can get it to work, but it may require more hoops to jump through, perhaps, or maybe a little bit more maintenance. It kind of depends on what you're doing. And I hope I answered that question well. That's to narrow down the choices and then to look at really what your use cases are, the problems you're trying to solve, and what kind of data sources you have coming in, what your needs are. One last thought on that is Snowflake really is kind of a out of the box, tries to be everything. Whereas if you're using like Synapse, for example, you will use Synapse, but also one or two or three other Azure services with it. So it could require a little bit more of a skills update for your engineers. There are those kinds of considerations to make, but I hope I've made it clear that they're relatively interchangeable. Thanks for the question.
All right, got one more, and if any of you guys have questions, definitely enter those into the chat. This one, in regards to upgrading your skills, are there things that I need to start changing now so I can keep up and don't get left behind, or is there a natural progression that is kind of happening natively in the industry?
The native progression is that many of the old skills and approaches still apply. They're just becoming part of and blending into this new environment. So if you're an old school relational database guy like me, that's my background, those exist in the cloud and they will be part of your overall architecture in a modern data architecture. But instead of being 80% of the picture, it'll be 20% of the picture. So there is some evolution there. I mentioned the education is key earlier. Getting certified and doing that kind of validation of skills just to increase your own awareness, I think is really important, because I think what you don't want to do is get caught behind. There is a wave right now, and if you want to catch it, it does require a skills upgrade. It really does. I would recommend, the industry is evolving, and I would recommend evolving with it. To accomplish that, the skills upgrade is definitely a part of it. Yeah, that's the answer. Thank you.
All right, and we got another question that asks, how do we sell this kind of data transformation to our organization?
Selling it within the organization, or even coming from the outside, a lot of the talk comes around shifting resources around. If you have a team of DBAs, as you shift to modern data, those DBAs can now do more data engineering tasks and cloud architecture infrastructure tasks, and will not have to spend as much time on provisioning disk space, managing backups, dealing with server outages or what have you, restores, disaster recovery and replication is all handled rather seamlessly. So your resources can shift their focus from those things to other potentially more valuable efforts. That's one of the big shifts that the modern data allows for us. And in terms of selling, I mentioned two things: an assessment of where the organization is at, just to kind of shed some light on, well, how mature are we? How much can we leverage now? Can we just migrate to the cloud tomorrow and off we go? Is the business a great partner in us? Is there trust between the business and IT? Do they trust our data? Those kinds of questions play into it. So an assessment, understand where the organization's at, and then what it can take as the very first step is a key part of it. Identifying that first step Oftentimes it's a data lake, but not always. And establishing an incremental move towards this new environment. By the way, I don't know if I mentioned this before, but on the incremental change, the cloud really enables this as a really good option because of the pay-as-you-go model. You're only, for the most part, going to use what you're using. Going to pay for what you're using in the cloud. So an incremental change there, putting one data mart in the cloud or just a simple database, what have you, is not going to cost an arm and a leg, and it helps to expose the organization and all the technical folks and maybe some business folks too to what this new world looks like. So that's probably the best way to sell, and because not everyone's ready for just change everything overnight. Thank you.
All right, that's all the questions we have. If you're watching this and you want access to this recording to go over it again, this will be posted on our YouTube channel. I just posted a link to that in the Q&A, and you can get access to lots of other recordings there as well. But I am out of questions over here, Chadwick.
Okay, thank you, everybody. I hope you have a good rest of your Friday and have a great weekend. Thanks for joining us.